Ever worked on a project where it's going smoothly until you put everything into your final assembly? All of a sudden, it feels like performance has come to a screeching halt. Is it so bad that it feels like a Boromir meme? If this is you, then I'm going to change you from a Boromir into a Mando. This is the way. I'm going to show you how to find what's causing your performance issues and how to fix them. We're going to focus on 2 commands inside SOLIDWORKS that'll do just that. First up, the Assembly Visualization command. This command can be found underneath the Evaluate tab. Once you activate it, move the mouse pointer over and click on the stoplight. The information columns update. We now see the name, quantity, graphics triangles, open time, and rebuild time. All the parts have been reorganized with the parts that are affecting performance filtered to the top of the list. The number of graphics triangles is a great indicator of what's impacting performance. Now the question is, how do I fix this? For assemblies, go to your System Options, then Document Properties tab, scroll down, and select Image Quality. Now move the slider bar to the left, preferably below the 25% mark. Now check the box next to Apply to All Reference Part Documents. Next, click OK and Rebuild. The Property Manager updates with the new graphics triangle numbers. If the assembly still isn't performing like shiny new Mandalorian armor, then we can look at another common occurrence. Fasteners with threads. Threads look great, but are unnecessary in CAD. They add complexity, increase file size, and are more computationally taxing. A better method is to have a simplified geometry with a shaded cosmetic thread. The SOLIDWORKS Toolbox provides this type of hardware. Once exchanged, Assembly Visualization shows the difference. Now, on to our second command for interrogating assembly files. When we click on the Performance Evaluation command, we get a pop-up window that provides a lot of information. We see information beyond what was provided in the Performance Analysis Assembly Visualization. Under the Open Performance section, we see items with long open times. There's also a list of all files that are from previous versions of SOLIDWORKS. Older file versions cause performance issues since those files have to be converted every time the assembly is opened. Next are any files that were modified upon open. These files weren't up to date when the assembly was opened. Next is Display Performance, which starts by showing the total number of graphics triangles associated with a particular file. This total is calculated based on the quantity of the part multiplied by the number of instances of that file in the assembly. Shaded Image Quality tells us if we have any parts that have image display settings set to medium high or very high. Last in this section is any files that the display speed would be improved by enabling the large assembly settings. Next is Rebuild Performance, which checks for circular references, the number of mates for the assembly, and the Assembly Rebuild Report. The Assembly Rebuild Report only shows items that take more than 10 milliseconds to rebuild. Settings Performance shows if the Verification on Rebuild option is toggled on or off in our system options. It also shows the current large assembly threshold settings and if they are on or off. Statistics gives a full breakdown for our parts, subassemblies, assemblies, and components. It gets into some pretty granular data. For example, if you have any flexible subassemblies, it shows the number of flexible subassembly mates. You can save out the data from this report as an HTML file to share with other members of your team. You can even access that handy Assembly Visualization command from inside the Performance Evaluation command. Now you can take aim at any poorly performing assemblies with confidence. Good hunting, everyone.